Hi class, it's Bill Berry with another video in the Programming with Repetition series in IT 102 Introduction to Programming with JavaScript. In the first video we looked at what looping was for, why we needed it, how we use it, some scenarios, gave you some examples of why you'd use it in real life examples. We also looked at the kinds of loops that we were going to be using. We looked at the while loop, a loop that used a condition to decide how far to keep going, how long to repeat. The second video we switched over and we talked about for loops, and for loops are generally based on counting. So we run the loop a certain number of times based on the data that we can easily determine. And we also have done some examples along the way to help you understand how to put them to use in code. And of course there's no exception here. We're going to do some more examples, but in fact let's take a quick look at some different ways loops can be used. These aren't new kinds of loops. They aren't anything new in terms of technology. They're just kind of an interesting way to think about different situations in which looping can solve some problems with you. So let us jump down there and let's take a quick look. First thing is, what if you need to enter multiple items? So far, we have typically done data entry with a single item. Enter this, enter that, and then we're sort of done. But we know that now that we have loops, we can do multiple things. So for instance, we can enter multiple grades, and then we could, figure out an average if we wanted to, or a count of the grades and things like that. So here is a simple loop that can be really useful. You might recognize this as being a priming the pump kind of scenario based on earlier discussion. So here's what the code might look like. Write out a nice header, right? Heading 1, big nice word, grades. We then create a grade variable and we assign it to the conversion to a number of a prompt asked of the user to enter the grade. Now this is another example of a sentinel, right? We've said to the user, hey, you can type in -99 when you're tired of entering grades and I'll let you out. So this -99 is a sentinel. Notice because the grade is going to be numeric, then we use a numeric sentinel. If we were using a text, some text to mark this, a text to manage the loop, we would use something other than -99. We'd probably use some other word like done or something like that. So we ask for this grade and then we store it. Then we set up a loop that says while the grade is not equal to -99, which is our sentinel. Now, the key with the priming the pump thing that we've started using it before, but this is a little more complete example. The other thing that we need to do is, because in the loop we need to make progress toward the goal, which is the grade eventually being -99, we need to ask for it again. Otherwise, it'll always have this grade and it'll never ask and will never make progress to -99 unless it happened to be the first and only thing they entered. So the important thing to do is right before the end of the loop, you put the same exact code that you put here, right? You don't need var again because you already have the variable, but you put the same code exactly. So you're gathering the new grade, which starts a new iteration of the loop. Now, very important note here, do not put anything between this line and this line. This must be the absolute last thing right before the end of the loop, right? So anything else that you need to do in here between the while and this inside the curly braces, right? So in this case, we're just writing out the grade, but if we wanted to average it or add it or count it or whatever else kind of good stuff you want to do while you've got the grade in your hands, you've got to do it here. The other thing to note is because we're replacing each time, we're assigning a new value to the variable grade, we are discarding the previous grade. So this is a scenario in which you better handle everything again right here in this section of code because you won't have the grade around after that point. Later in the quarter we'll learn how to use arrays, lists basically, and we can store multiple grades so we don't have to discard them each time. But for the moment, this is what we can do. So great example of entering multiple items, and this is another example of this priming the pump thing. And so again, the -99 we'll call a sentinel, right? It stands guard, and when we see that sentinel, it knows that something needs to happen differently. In this case, we need to exit the loop. So that's one quick example of a great thing to use loops for, data entry. Then there's more notes about priming the pump, and discarding is exactly as I've said. All right, so next example, counters and accumulators. Have you ever seen one of these devices, somebody using one of these? Right, it might have been a while, and maybe you haven't paid much attention because it's not that typical these days, but you can have this little manual counting device that you hang on your hand. There's a little loop to put it around your finger so you don't drop it, and there is a little thing at the top that you simply press. When you press that button, that little device, will count up by 1. And there's a knob here to reset it so that you can dial it all back to 0 when you need to start over again. But when you're working at an event or something like that, you just simply click each time a person comes by or each time something happens, and that will count how many things are going on. Well, that's a great example because that works a lot like programs are gonna work with this idea of a counter, right? So again, if you can find some good analogy in real life, you can apply it sometimes to programming. Because how would you tell a child to go do this? You have somebody who's fairly young, or let's say somebody who's a little bit dull and not so bright maybe, and you have to tell them exactly what to do. So how would you express this, right? You would say, first, turn the dial to make sure that all the numbers are at 0. You've got to start at 0, right? Zero it out before you start this whole process. Then, every time a person walks by you, click this button. When you click this little thing, that's all you need to do, right? And when we're all done with the event, then you hand the thing to me and I'll be able to see how many people came through, right? So this is a great example of a counter. So very often we want to count things much like that, and sometimes we also want to sum them or accumulate them. So for instance, when customer balances are being entered within the loop, you want to sum those all up so you know what the total of all the balances. Maybe that's the accounts receivable total or something like that. So all of these things are easy to do with variables and loops. So let's take a quick look at what those look like. Here's an example of a counter. Right? So in this case, I ask the user to guess the word, right? And I don't tell them what it is. In this case, it's kind of boring because the word is always abracadabra, but that's okay for the moment. So you ask them to guess the word, but you set up this guess count at the beginning before the loop, and you set it to 0. You need to set it up before the loop because we need it to be available after the loop and have the right count, right? So typically, outside the loop, set up the counter, set it to 0. Inside the loop, do whatever you need to do, right? This is another priming the pump thing, right? You're asking them the question here, you're asking them the same question here. Inside here, you do whatever else you need to do, and this includes incrementing the counter, right? Just ticking it up by 1 using the plus plus operator. Then after the loop, we know that everything's been counted. We know how many times they tried because it's been counted in this guess count variable, and then afterwards we can use that counter. The same thing works with an accumulator. The only difference is, as you'll see, there's one other little subtlety. You set up the accumulator variable like grocery total, set it to 0, and then you ask them a question, input the item price. So as you're going through, pricing out stuff that you're going to buy at the grocery store, you want to know about how much your total is. So you're going to enter the item prices, again, priming the pump because you're going to ask the same question again. You're going to have a sentinel value, which is negative 9.99. That really needs to be here in this little prompt message. Just didn't have room on the slide. But here's the difference. Whereas with the total, you increment it by 1 each time through the loop. With an accumulator, you add to that total whatever it is that you're tracking. In this case, we want to total up the item prices that are entered. So therefore, we say grocery total plus equals item price. That says take the grocery total that you had before, add to it the item price, and store it back into the grocery total. That would be the same, again, as saying grocery total equals grocery total plus item price. So notice that's different. Here you're adding 1. Here you're adding whatever it is that you're totaling. But you're still setting up the variable, setting it to 0, etc. And so afterwards, after the loop, you know that you've totaled up all the item prices that have been entered. But because of the priming the pump, you don't total up the negative 99. Same here. We don't total up the extra thing if they actually guess the thing right, it doesn't count again, right? So this priming the pump thing is very convenient this way because we know that the sentinel value is not going to be included. That's pretty good, right? That's important. All right, so that's how counters and accumulators work. Now, one other thing that we can do that's pretty handy is data validation. where validation means we've got to make sure they enter it right. Now, we've done this with forms before, but we haven't done it yet with other kinds of code, right? Non-form code. So again, we're going to use a priming the pump sort of idea where we ask them a question once and then ask them again at the very bottom of the loop. But here, the loop condition, rather than counting some other thing, we actually are not keeping track of anything else, but if they give us bad entries, we just ask it again. So the loop says keep bugging the user, keep pestering the user until they comply, right? Until they give us the thing that we want. So in this case, the loop condition, you notice, is the bad stuff, right? Any possible bad conditions, bad data, all goes here. So in this case, we ask them for the number between 1 and 10, and we say, hey, while the user's answer is less than 1 or the user's answer is greater than 10, that means they gave us bad data. So not going to work. So ask them again. This will continue to ask them over and over and over until they give us a number that is not less than 1 or greater than 10, which means it must be 1 to 10, all right? It must be exactly what you asked for. So this will keep them locked in this loop forever until they comply. As soon as they enter a number from 1 to 10, then it lets them out, and therefore you know you have a valid number. So one of the things, of course, you got to tell them here, right? Don't make them guess what the validation is asking. Make sure you tell them, right? Enter a number between 1 and 10. But data validation is a cool thing that you can do with the loop. Lock them in until they comply. Now, another thing that we can do is build up strings, right? In the loop, you can create a longer string by concatenating on shorter strings that are entered as you go. So in this example, you ask the user for a word, and each of those words that they enter is going to be concatenated into a variable called sentence. So you're saying sentence plus equals whatever word they entered, and then we're also concatenating on a space because you don't want the sentence to run all together without any spaces. So the user enters a series of words and we add them together, add in quotes, concatenate them together with a space so that you're going to get a whole sentence out. So the boy ran down the street, right? So each word gets added to the sentence, and then down here the variable sentence contains that built up string. We often do that character at a time, right? They enter one character and we're sort of creating a bigger string, or it doesn't have to be user entry, it can be other things that build up strings as you go, right? Now there's another slide here that shows the way that you can solve the multiplication table in a little prettier fashion. I'm not going to stop and talk about it here, but if you want to pause the slide and take a look, it uses a pre-formatted block in HTML, which is a very handy little thing to know about when you want sort of blocky monospaced output. All right, one more area, and that's going to be finding the min and max. But I'm going to pause the video or stop the video here because this one's getting long. So we'll do a video, one more video that is finding min and max, and then also walks through a slightly more complex challenge project, and we'll walk through pseudocode for that together. So let's stop this video. Thanks for watching this one. Continue on with the next one on min and max and some more examples of coding with loops and other control structures. Thanks for watching.